Hello everyone, welcome back to Tutoratti and I am Vibhuti. If you remember, last time we completed half the chapter and let us discuss the remaining half of the question paper. So let's start with question number 10th, all of you, which is on your screen if you can see. Let's start with question number 10th. The 10th question asks, write the preparation of phenol from aniline. So if I have to make phenol from aniline, let us first see what is aniline. So this is your aniline, right? Now to convert aniline into phenol, what I'll first do is I'll take NaNO2 and HCl, in the presence of which this aniline will convert into N2 plus Cl minus, which is nothing but your diazonium salt, which further on treatment with warm water is going to give you, in the presence of warm water, it will produce the required product, which is phenol. So that's question number 10th, students, asking about the preparation of phenol using aniline. Moving on to question number 11th, everyone. Now, question 11 says, write the chemical reactions to prepare ethanamine from acetone nitrite and from nitroethane. So let us first understand what is ethanamine. When I say ethanamine, it's quite simple. It is CH3, CH2 and NH2. So we are actually supposed to prepare this using acetone nitrite and nitroethane, right? So let us start with the very first one, which is acetone nitrite. Now when I say acetone nitrite, it will be CH3, C triple bond N. Now if I have to convert this acetone nitrite into ethanamine, what I'll do is, I'll add hydrogen over here in the presence of sodium and ethanol. This will result in the formation of the required product, the formula which I already gave, which is ethanamine. Moving on to the second part of the question, which is, prepare ethanamine using nitroethane. Now when I say nitroethane, the formula again is simple, CH3, CH2, NO2. Now let us convert this nitroethane into ethanamine, and to do that, I am going to simply take over here lithium aluminium hydride, and this lithium aluminium hydride in the presence of ether will give me my required product with the help of nitroethane, which is ethanamine. So that is your question number 11th, part 2. Question number 11th is done. We are done with 2 questions. Moving on to question number 12th. Now the 12th question is, identify A and B from the following reaction. The reaction is given to us. We just need to understand what will be A and what will be B. Let's start with it. Now the reaction says they have given us CH3, CH3 double bond O, right? In the presence of barium hydroxide. So what will happen? Let us look at the product A here. If I have to make A from this, what I'll do is, I can write this as CH3, C, CH3, right? One OH will come here, then again C, then I'll have H, H, C double bond O, CH3, since 2 molecules of acetone is given to us. So I get this. Now this is my A. Now they are saying make B as well. And the best hint provided here is that they've given us the byproduct water. That means if I remove water from here, this will give me my product B. So B will be what? Remove this water. If I remove this water, this will give me C, CH3, CH3. Now we need to also satisfy the tetravalency of carbon, so I can make a double bond here, CH, C double bond O, CH3, and that's your B. So that is how you can identify A and B given in the following reaction, right? Let us take this ahead with the next question, which is question number 13. Question 13 says 1 mole of an ideal gas. This question is directly from your textbook, so you can check the answers there. The entire solution, I'll give you the answer for sure. 1 mole of an ideal gas is expanded isothermally and reversibly from 10 liters to 15 liters at the temperature of 300 Kelvin. The question is asking calculate the work done in the entire process, and the work done in this is going to be minus 2.023 kilojoules. That should be your final answer. The question is directly from the textbook. Moving ahead to the next question. Question number 14th, everyone. How many moles of electrons are required for reduction of 2 moles of Zn2 plus to Zn, and how many Faradays of electricity will be required here? The question is quite simple. See, the first thing they are asking is the number of moles of electrons, correct? And they have given us that there is reduction taking place. Now what is reduction? Addition of electron, gain of electron. So when I talk about Zn2 plus, I can write Zn2 plus will gain 2 electrons and convert into what? Convert into Zn. Now if you look at this reaction, 1 mole of Zn2 plus requires 2 moles of electrons. I can simply do the cross multiplication thing. 1 mole of Zn2 plus requires 2 mole of electrons. So the question is asking for 2 moles of Zn2 plus, which means that 2 moles of Zn2 plus will require definitely 4 mole of electrons. So number of electrons required will be 4 mole. That's the first part of the question. Now the second part is how many Faradays of electricity will be required. 1 mole of electron requires 1 Faraday. Therefore it's quite simple. We have got 4 moles of electrons here, which means 4 moles of Faraday will be required. So that's your question number 14. We are done with it. Moving on to the next one. Now let's start with section C. Question number 1. Write the chemical composition of hematite. What is hematite? Hematite is the ore of iron. And if I have to write the composition of hematite, the composition will be Fe2O3. Now since it is the ore, it definitely will be having other impurities which are also called as gangue. So if I need to write other impurities, they are Al2O3, then we have SiO2, we have phosphates. So this is nothing but the chemical composition of hematite. Alright, the next part of the question is, write the names and electronic configuration of the first 2 elements of group 17. Now when I talk about group 17 is nothing but halogens. Now the first element is fluorine, then we have chlorine. We need to write the configuration of the first 2 elements. Now the atomic number of fluorine is 9, so if you write the configuration, it will be 1s2, 2s2, 2p5. And if I talk about chlorine, the atomic number is 17. The configuration will be 1s2, 2s2, 2p6, 3s2 and 3p5. So that's your question number 15th done. Alright. Moving on to question number 16th, students. Question 16th is, write the classification of polymers on the basis of structure. Now on the basis of structure, you have got 3 types of polymers. One is linear or straight chain polymers, one is branched chain polymers, and the last one is cross-linked polymers. So that's your question number 16, very simple. Moving on to question number 17th. Question number 17th is, define green chemistry. Green chemistry is very much famous nowadays. It is the branch of chemistry or the science that we are utilizing which specially designs eco-friendly or environmental friendly products which eliminates or reduces the risk of damage. That is what green chemistry is. Then the next part of the question is, write 2 disadvantages of nanotechnology. Nanotechnology mainly has the disadvantage of creating pollution. It creates a lot of air pollution, and that in turn creates biological issues like it affects the respiratory tract and causes damage to the lungs. So those are the 2 disadvantages of nanotechnology. Moving on to question number 18th, everyone. Write the commercial method for preparation of glucose and also write the structure of adipic acid. So let's first talk about the commercial method of preparation of glucose, which you all must be knowing. It is using starch as the raw material. So if I talk about starch, it will be C6H10O5, N molecules if you take. You simply add water to this and this will result in the formation of C6H12O6, that is nothing but glucose. So that's how glucose is commercially prepared in the industries. Now, the next part of the question is write the structure of adipic acid. Structure of adipic acid, very simple. So, this is going to be your adipic acid. Here, OH, and similarly you can put OH here as well. This is your adipic acid, students. So that's your question number 18th. We are done with question number 18th as well. Moving ahead, let's take the next page. Alright, moving on to question number 19th, everyone. Next question is write the chemical reactions of following reagents on methoxyethane, which is CH3O, CH2, CH3, right? Let's start with the first reaction, which is hot HI. So when I talk about methoxymethane reacting with hot HI, let's see how the reaction will come. So I'm taking over here CH3O and CH2, CH3, which is nothing but methoxyethane. Let's add to this HI. The reaction, if you remember, is very, very simple. Nothing will happen. Just this H will come over here, giving this a positive charge, and I minus will come and attack this, resulting in the formation of CH3I, and the remaining will be ethanol, which is CH3, CH2OH. That is the first one. Moving ahead to the next one, the second part is reaction of methoxyethane with PCl5. We'll simply make halides, chlorides in this case, because it's PCl5. So if I take reaction of this with methoxymethane, which is CH3O, CH2, CH3, then this will result in the formation of CH3Cl and also in the formation of ethyl chloride, which will be CH3, CH2Cl. And since phosphorus is still remaining, this will convert itself into POCl3. That's your reaction. Now, the second part of the question is with dilute sulfuric acid, everyone. When I say dilute sulfuric acid, it will just convert into alcohol. So, when you take dilute sulfuric acid, you will get methanol, you will get ethanol, that's it. That's our question number 19th. Now, moving on to question number 20th, everyone. Now, question 20th says, explain cationic, anionic and neutral sphere complexes with example. Sphere complexes, complexes is nothing but coordination compound. So, when I talk about cationic, it means the coordination compound in which the bracket, that is the coordination sphere, must have a positive charge. When I say anionic, in which the bracket must have a negative charge, and when I say neutral, the bracket shouldn't have anything, right? So when I talk about the cationic complexes, the bracket must be having a positive charge. So let us take an example of a cationic complex. Let us take it over here. I can write CO NH3 6Cl3. The most important compound taken by the scientist Werner. The entire theory was based upon this. So if you look at this compound, what will happen here? This is Cl3, right? Having a charge of -1 each. I've got 3 Cl over here, which means the overall charge will be -3, which gives the sphere a charge of +3, and this is nothing but a cationic complex. Similarly, if I have to talk about an anionic complex, then the sphere must have a negative charge. Again, you can take the best example of Fe. So if I talk about the anionic complex, then the example could be K4 FeCN6. The charge on potassium will be +1, it belongs to group 1. So this is +4 because there are 4 potassium, giving this a charge of -4, which means the charge on the coordination sphere is in negative, and that makes this an anionic species or an anionic coordination compound. Moving on to the next one and the last part of this question, neutral sphere. Neutral sphere means the complex, the coordination sphere, it should not have any charge. And the example of this is NiCO4. So that was your question number 20 with examples. Cationic complexes are those in which the complex sphere or the coordination sphere contains a negative charge. Similarly, for anionic, it will be for cationic, it will be a positive charge, and for neutral, it is going to be 0. Right? Moving on to the next one, question number 21, everyone. 21 says calculate spin only magnetic moment of a divalent cation. Divalent cation is a hint here. Of a transition metal with atomic number 25. So my metal is having atomic number 25, so I'll simply write 25, right? When I say 25, we all know it is Mn. Now let us write the electronic configuration. The electronic configuration will be Ar3d5 4s2. It says, the question clearly says divalent, which means 2 positive. It's a divalent cation. So remove 2 electrons. When you remove 2 electrons, this becomes 4s0, this becomes 3d5, and you have got Ar. Now let's focus on this 3d5. When you do the orbital representation, then here are the 5 orbitals of D, and let us start filling 5 electrons. 1, 2, 3, 4 and 5. There are 5 unpaired electrons, and if I have to calculate the magnetic moment, then the formula for this will be mu is equals to root of n plus 2, and the unit is Bm. Let us figure out this. Now n is nothing but the number of unpaired electron. In this case, the number of unpaired electrons are 5. Simply put the value 5 here. So you're going to get 5 plus 2, which is going to give you root 35, which in turn gives you 5.9 Bm. That's your final answer, nothing but the magnetic moment of a divalent metal having atomic number 25. That's your question number 21, everyone. Then it also has one more part. I hope this much is clear. Let's move on to the second part of the question, which is salts of Ti4 plus are colorless. Give reason. See, being colored or colorless completely depends upon the unpaired electron. So I simply need to find out the unpaired electron. If it has unpaired electron, it should be colorless. It should be colored, sorry. And they are saying it's colorless, it simply means it do not have any unpaired electrons. Yes, we do have exceptions, but not in this case. So when it comes to Ti4 plus, I'll simply write titanium, which is 22, having configuration Ar3d2 4s2. Now the question says it's 4 plus, which means I'm supposed to remove 4 electrons. So when I remove 4 electrons, 2 will go from here and 2 will go from here, which is going to give me Ar3d0 4s0, telling me that there are no unpaired electrons, therefore it is going to be colorless. So why is it colorless? Because it do not have unpaired electrons. That's your question number 21. Moving on to question number 22, everyone. Now question 22nd, it says, what is lanthanoid contraction? See, lanthanoid contraction is the gradual decrease in the atomic radius from left to right in the lanthanoid series. That is called as lanthanoid contraction. Alright, I hope lanthanoid contraction is very much clear to you all. Nothing but the gradual decrease in the atomic radius from left to right in case of lanthanides, and the same property is also applicable to actinides, right, which was called as actinoid contraction. Let us move on to the next one now. Write the preparation of acetic acid from dry ice. Now when I say dry ice, it is nothing but CO2, right? So I'll simply take CO2 here. That's your raw material for the preparation of acetic acid, and using this you can make dry ice. Let's see how that will be done. In this we are going to add the most common organic reagent, which I told you last time as well, Grignard reagent, RMGX. So since you are preparing acetic acid, so we are going to take, instead of R, I am going to take CH3, right? So you can take CH3, Mg, and you can take R, and you can get the product. That's the first part. The second part is the preparation of acetic acid using acetyl chloride. Now what is acetyl chloride? CH3COCl. So I'll simply write over here CH3COCl, take some water and get the answers. That is going to give you the required product. Moving on to the next question, which is question number 23, everyone on the screen. Question number 23 is, write the classification of aliphatic ketones with examples and what is the action of sodium hypoiodide on acetone. Let's first take the first part of the question, which is classification of aliphatic ketones. When I say ketones, ketones can be categorized into two parts. One is simple ketones or symmetrical ketones. which means both the R group should be same. Like if I say acetone, it's CH3CO CH3. Both the R groups are same. That's called as simple or symmetrical. And the other one will be mixed or unsymmetrical. Like one is CH3 and one is, let's say, C2H5. So it will be ethyl methyl ketone. So we have got two types of ketones, everyone. One is simple or symmetrical and the other one is mixed or unsymmetrical. Moving on to the next one, which is, what is the action of sodium hypoiodide on acetone? So let's take this. When I say sodium hypoiodide NaOI, just take acetone, which is CH3CO CH3, resulting in the formation of CHI3, and with that you are going to get CH3COONA. That's your answer for question number 23rd, everyone. Moving on to the next one, the next question is, define half-life of first order reaction. Half-life is nothing but the time taken by the reactant to reduce into half of its original concentration, that is half-life. Obtain the expression. When it comes to the expression, there is an entire derivation, and I'm just telling you the derivation which we are supposed to do. The derivation is T half is equals to 0.693 upon K half. This was the derivation required for this particular question. Alright, so that's your question number 24, all of you. Moving on to the next question, which is question number 25. Question 25 says, calculate the standard enthalpy of formation of CH3OH from the following data. Data is given to us. You just need to reverse this one, which will give you the value as from minus 726, it will become plus 726, minus of this, but since you are getting 2H2O here, so this will become twice, and that, so minus 726 minus 393 minus 2 into 286, and that is going to give you your answer, and your final answer, when I calculated, it comes minus 239 kilojoules per mole. It comes out to be minus 239 kilojoules per mole. That's your answer for question number 25th, everyone. Alright, moving on to the next question, question number 26th. Question number 26th is, calculate the pH of a buffer solution composed of 0.001 molar weak base BOH and 0.02 molar of its salt BA, and they have given you the Kb value, which is 1.8 into 10 raised to the power minus 5 for the weak base. So you are supposed to calculate the pH, but since it's a base, we'll first calculate the pOH, and after that you will get the pH. Again, the question is exactly from your textbook, having the answer as 8.96. In the textbook, it is one of the in-text question where the subtraction is done wrong, but otherwise the answer is perfectly right. The answer is going to be 8.96. Alright, so that's question number 26, everyone. Moving ahead, let's take the next page, which is alright, let's take the second last page, sorry, question number 27th, everyone on the screen. The first question is, write or define the following terms. Number one, isotonic solutions. When two different solutions, they have the same osmotic pressure, as simple as that. Next one is osmosis, when there is a solution and it's solute, or maybe there are two different solutions having different concentrations and they are separated by a semi-permeable membrane, and then the solute moves to the semi-permeable membrane. That is called as osmosis. Question number 27th, as it is from your textbook, the question is to figure out the density of gold, which is in the form of FCC unit cell. So if you calculate this, or if you can check the entire process, the entire mechanism from your textbook, the final answer will be 19.27 grams per cm cube. The density will be 19.27 grams per cm cube, everyone. So this is question number 27th. Alright, moving on to the next one now. Question number 28, all of you. Now question 28 is write the mathematical equation for the first law of thermodynamics for the isothermal process. So when I say isothermal process and we are supposed to write down the mathematical equation, it's quite simple. W is equals to minus Q, right? And the next one is for an adiabatic process, which will be minus delta U is equals to minus W. So these are the equations for these two processes. The next one is derive the relationship between pH and pOH. Very, very simple. From the chapter ionic equilibrium, pH plus pOH is equal to 14. You are supposed to derive this entire relationship. Alright, so here we are done with question number 28 as well. I hope you did it right. Moving on to the next one. The next one is question number 29th, everyone. 29th is define reference electrode. Reference electrode is the electrode in which we accurately maintain the potential so that we can use other electrodes. The other electrodes that we are taking, they are actually going to refer this for measurement. So that is your reference electrode. Write the functions of salt bridge. Salt bridge basically connects two solutions in such a way that the electrical circuit is complete. It separates the two solutions. It do not let them mix with each other. So these are the uses of salt bridge or the functions of salt bridge. The diagram of standard hydrogen electrode, you can check it from your textbooks. Hope you did it right. Alright, let's move on to question number 30th, everyone. Question number 30 says, explain metal deficiency defect with an example. So let's take example of Ni. So if I have got nickel oxide compound or solid, definitely in the entire solid there will be Ni, there will be O as well, right? Ni being a metal will have a positive charge, O will be having a negative charge. Now let's assume it like this. Let's say in this, since the name is metal deficiency, so few of the Ni will be missing in the entire crystal lattice of NiO. When that happens, the positive charge decreases. Now we need to do something to balance the missing positive charge. So what we can do is, or what we find is that metal is present within the lattice having higher oxidation state. So if 2 Ni plus 2 are missing, I can replace those 2 missing by Ni4 plus, so that the charges are maintained but still Ni2 plus ions are missing, and that is called as metal deficiency defect. The next part of the question, write chemical equation for the preparation of sulfur dioxide from sulfur. S plus O2 gives you SO2, very simple. And the last part, uses of sulfur. There are so many uses of sulfur in batteries, fireworks, gunpowders, industries, medicines, manufacturing of sulfuric acid, manufacture of SO2, and so on. Right? So we are done with question number 30th as well. Let's look at the last question, which is write the chemical reactions for the following conversion. Let's take the first one, which is ethyl bromide to ethyl methyl ether. So when I say ethyl bromide, as we all know what it is, it's CH3, CH2, Br, correct? We need to convert this into ethyl methyl ether. So if you want to do that, you are going to take over here NaO, CH3, and that is going to give you the product. Fine. The second part is ethyl bromide to ethene. So you will take again what? CH3, CH2, Br. Simply add to this alcoholic KOH, which will give you the product. Right? The next one is bromobenzene to toluene. So if I take bromobenzene, this is your bromobenzene. I need to convert this into toluene. When I say toluene, there has to be a CH3 group. So to this we are going to add CH3Br in the presence of Na and definitely dry ether, which will result in the formation of toluene, everyone. That's the third part of the question. Moving on to the last part of question number 31, which is chlorobenzene to biphenyl. When I say chlorobenzene, it is this. Take 2 molecules because we are supposed to make biphenyl. So take this, simply to this we are going to add Na. Again in the presence of dry ether, this will result in the formation of biphenyl. phenyl everyone. So that is what the entire paper is about. We are done with section D as well. This was your chemistry paper of your board exams. I hope you did it well. We are done with the entire paper discussion. The paper started, I'll just show you the first page again. The paper started from here. Section A was done, MCQ, section B, theoretical questions, C and D as well. So we are done with all the theoretical questions, all the MCQs and all the numericals as well, right? So this is all about your chemistry paper. I hope you found this useful, and thank you all so much. All the best everyone. Thank you.